So today we're going to talk about the natural base, e to the x and ln. So our essential question is, what is the natural base and how is it used? Our learning objective is to use the number e to write and graph exponential functions representing real-world situations. We're going to do more of the real world on Monday. So what is the natural base e? The number. So if you were to take on your calculator e to the first, then you would get this number, 2.718281828 ... would keep going. And this number has to do with compounding continually. That's where that number came from. So the natural exponential function is f of x is equal to e to the x. So exponential functions with e as the base have the same properties as functions that we've studied before. So the graph of f of x equals e to the x is like other graphs of exponential functions, such as f of x equals 3 to the x. So that's a growth function, right? So I want you guys to notice here that as I'm going to the right, it continues to go to the right, and as I'm going to the left, it continues to go to the left. So the domain is, again, all real numbers, right? And then when we're talking about the range, notice that everything in this graph is above this line right here, right? So our asymptote would be what? Y is equal to 0, right? So what does that tell us about the range? Then all of our range is y is greater than 0. So now what I want you guys to do is on your calculator, I want you to find the e and the ln. So I'm going to show you where it's at. Hold on just a sec. So over here on the left, if you go down 1, 2, 3, 4, 5, 6, 7, 8 to the ln right here, if you use second ln, then you will see that that's where your e is, okay? If you just do clear ln, then that's where you're going to put in your values, okay? So for our first one, we're going to do, clear this out, we're going to do second ln, which is e, to the second power. We're going to go ahead and put that in the calculator and then push enter. And so it says do it to the 10th, which remember the 10th is 1 decimal place. So it's going to be 7.4. So go ahead and do the rest of these and then come back to me when you're done. So this one was 7.4, this one was 1.6, and this one was 0.4. Okay? So now, when we talk about the natural logarithm function, a logarithm with a base of e is called a natural logarithm. So and it's abbreviated as ln rather than log base e. Natural logarithms have the same properties as log base 10 and logarithms with other bases. So the natural logarithmic function f of x is equal to ln of x is the inverse of the natural exponential function f of x equals e to the x. So when we're talking about y is equal to log base e of x, it's actually written as y equals ln of x. So these are inverses of each other over here. So y is equal to e to the x is an inverse of y is equal to ln of x. So what does that mean? So when we're talking about these, so a minute ago we looked at the graph of e to the x. I can't draw it right now, obviously. Let me see if I can go back and start this because it's going to run along that line. So it's going to come across here like this and then up and out, okay? So that is the graph of what? The first one we did, which was e to the x, okay? And this one, let me do that a little clearer. E to the x, okay? So this one, the domain was all real numbers, right? All real numbers. And then the range was y is greater than 0. Okay, so now when we talk about the graph of ln of x, it's going to come up and go out like that. So this one's domain is going to be x is greater than 0, and our range is now going to be all real numbers. So now I want you guys to do ln of each of these numbers. So we're going to evaluate f of x equals ln x. Again, we're going to round to the nearest 10. So this time, all we have to do is click this ln number, okay? And then go ahead and put our 2 in here, and then enter. Whoops. Sorry, y'all. ln of 2, enter. So this one is 0.69, which would be 0.7. So go ahead and do the rest of these and then come back to me when you're done. So this one is 0.7. This one was negative 0.7. And this one we got an error message for. And that is because, look back here at the graph, we cannot put a negative number over here. Do you guys notice that, again, our domain is x is greater than 0. So if our domain's x is greater than 0, then we can't have a number less than 0. So for this one, what I want you guys to write down is you can't take ln of a negative number. Okay? So then, ln of x and e of x are inverses of each other. So when they are next to each other, they actually cancel each other out. So here, ln and e are next to each other, so the answer here is 0.15 of t. With number 8, you should recall that, again, if we have a number out front of a log, then we can take it back here and create it as the exponent. So I'm just going to write this like this, ln of x plus 1 cubed. So now these two are next to each other. So our answer is x plus 1 cubed. And this one over here, again, we got ln and e next to each other, so that's 2x. We got ln and e next to each other, so that's plus x. So 2x plus x is 3x. So in the example number 10, to solve this, we're going to have to use e. So we're going to have to get rid of the ln. So to do that, we're going to do e here and e here. So once again, these are next to each other. So we have x plus 4. And then when we do e to the 9th power in our calculators, we get 8,103.08. When we subtract 4 from that, we get x equals 8099.08. Okay? And if we were to take ln of that 8103.08, we would get 9. All right, so over here, again, we have e and ln next to each other, so we have x to the 8th is equal to 65,536. Hopefully you remember that the way we get rid of an 8th power is to take it to the 1/8 on both sides. So this is going to be x is equal to 65,536 to the 1/8 power, which means x is equal to 4. Okay, for our next problems, we're doing inverses. So we're going to swap the x and y. So we have ln of y minus 4 is equal to x. We're going to add 4 to both sides. So we have ln of y equals x plus 4. So here again, we're going to use our e to get rid of the ln. So y is going to be equal to, and this is really the inverse of y, e to the x plus 4. Same thing with the next one. So this would have been y. So this is going to be x equals ln of y plus 6 plus 2. So we're going to subtract 2 from both sides. That's x minus 2 equals ln of y plus 6. We're going to use our e again to get rid of that ln. So we do e there and e here. So now our ln is gone. So we are left with e to the x minus 2 equals y plus 6. So that means we need to subtract 6 from both sides. So when we're talking about our inverse of y, which we could write like that, y to the negative 1, or f to the negative 1 of x, that's going to be e to the x minus 2 minus 6. So here again, x equals 2 ln y minus 5 minus 3. Going to add 3 to both sides. So we get x plus 3 equals 2 ln, which means 2 times ln. So then what are we going to do? We're going to divide both sides by 2. So we get x plus 3 divided by 2 equals ln of y minus 5. So now here's where we got to use our e again. So that's going to be e there and e here. So that gets rid of that. So I'm going to go over here, y'all. So this is going to be e to the x plus 3 over 2, and then that equals y minus 5. So we're going to add 5 to both sides. So this is going to be e to the x plus 3 over 2 plus 5, and that's equal to the inverse of y, or we could also say f of -1. And the only reason I'm showing you guys these different notations is so if you take a test somewhere else, you know how to do it. Okay?